Welcome to Ready to Derive. In this video, we will derive the derivatives, because that's how we roll on Ready to Derive, for tan x and secant x. While I will give you the formulas for cosecant x and cotangent x also, I will leave the pleasure of deriving the other two trig functions to you, the diligent student. We will then do a few practice problems as always. In order to follow this lesson, you will have to already know these two derivatives. So the derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. And you will also need to know the quotient rule, which all of these were covered in previous videos, and I can link to those in the description. So without further ado, let's get started. So let's begin by finding a formula for the derivative of tan x. So to do that, we have to re-express tan x as sine x over cosine x first, because those are the only trig functions we know the derivatives of. It's all we have to work with. But by doing that, we also see that we're going to be employing the quotient rule, which I'll pull up right here. And in doing the quotient rule, I like to kind of set up this little structure here so that we can kind of make sure we have all the components together before we assemble it. So in this case, u is the upper function. You can think of u for upper, and v is the lower function. So let's just put these in here. So u is sine x, v is cosine x, and that means u prime is the derivative of sine, which is cosine, and the derivative of cosine is negative sine x, and that's v prime. And then we need to assemble it into this quotient rule. And you can see here that the first thing we need is the product of u prime v, which is u prime v is the product of these two factors. So let's put that cosine x times cosine x minus, because it's the quotient rule, and then we need uv prime, which we see is the other diagonal here, uv prime. So we have, let's see, we have sine x for u, and then v prime is negative sine x. And that's all over v squared. So that's all over cosine x squared. Now let's tidy that up a little bit. Cosine x times cosine x we can write as cosine squared x, plus sine x times sine x is sine squared x, and that's all over cosine squared x. It's more convenient to write cosine x squared in that form so you don't need parentheses. Now, the next thing you need to realize is that the numerator is an example of the Pythagorean identity, which means that cosine squared x plus sine squared x equals 1. That's a result from pre-calculus. So we can rewrite the numerator as 1 over cosine squared x. And our last step is to recognize that 1 over cosine x is secant x, so that the final answer is secant squared x, which therefore is the derivative of tan x. So now we are going to find a formula for the derivative of secant x. Again, let's try and express this in terms of something we do know the derivative of. Secant x is 1 over cosine x. And so we have another quotient situation. So here's the quotient rule. Here is the structure. And we know that u is the upper function. So u is 1 and v is the lower one, the denominator. That's cosine x. So u prime is actually 0. Well, that's going to be convenient. And v prime is negative sine x. So when we assemble this into the quotient rule, we have u prime v. So u prime is 0 times cosine x minus, and u is 1, and v prime is negative sine x, all over cosine squared x. And if we tidy that up a little, then we would get left with the 0 would cancel out the cosine x, and then we have positive sine x over cosine squared x. That's a little hard to remember the formula if we just left it at that. It's still correct, but it maybe is not as compact as we could make it. So I'm going to do a little separation here and think of this as 1 over cosine x times sine x over cosine x. So we're going to separate out the cosine squared x. Well, why is that helpful? Well, that's because 1 over cosine x is just secant x, and sine x over cosine x is just tan x. And so we have a formula for the derivative of secant x is secant x tan x. And actually written like this, it's a little easier to memorize, as we will see in the next slide. At this point, we're going to fill in the trig derivatives of the trig functions we just worked out, and then also I'm just going to give you the formulas for the other two, and you could prove them by yourselves. In the same way, you'll be using the quotient rule for each of them. But for the derivative of tan x, we found that that was secant squared x, and the derivative of secant x we found was secant x tan x. Now, there's a great way to kind of remember which functions go with which, and that's so to look for patterns. So the most important pattern is to realize that tan x and secant x always go together. So if we look at here, so the derivative of tan x gets secant squared x, and here secant x and tan x appear together also. The other important thing to note is that the derivative of secant x begins with secant x, and then secant x is associated with tan x, and that's very helpful because it turns out the derivative of cosecant x, well, since it begins with cosecant x, it's only fair, since it is cosecant x, it's only fair that it begins with cosecant x. And then we bring in the other important fact is that cotangent x and cosecant x always go together. So this is going to be times cotangent x. And it's also true that since tan x got secant squared x, it feels right that cotangent should get cosecant squared x. My apologies. Let me just make that a little neater. So cosecant squared x. And then there's one other pattern, though, that you do have to remember, is that derivatives of trig functions beginning with c will be negative. So the derivative of cosine x is negative sine x. And since this begins with c and this begins with c, that should help you to remember to put a negative in front of those. So hopefully those patterns will help you to memorize the results. And like I said, you could figure out the derivative of cosecant x and cotangent x by yourself using trig identities and the quotient rule. So let's do some practice problems involving trig derivatives. So here we have f of x is secant x cosecant x, which you should recognize as being a product, and therefore we will set up the structure again as we did for the quotient rule. And u customarily is the first function, so u is secant x and v is cosecant x, but it doesn't really matter which you choose because it's perfectly symmetric. And now we learned that the derivative of secant x is secant x tan x, because tan x and secant x always go together. And the derivative of cosecant x, well, don't forget the negative, but we also begin with cosecant x, and this gets paired with cotangent x. Okay, so now we can put it together, and f prime x equals, so u prime v is our first part, u prime v once again, so that's again that same diagonal thing going on. So u prime v is going to be secant x tan x times cosecant x. Okay, there's quite a handful there. And then we have the plus, and now we have uv prime, so u is secant x, so that's the other diagonal, and negative cosecant x cotangent x. Well, this one looks like a sort of hard one to tidy up. There's so many functions there that perhaps some things cancel out. So let's just try and write secant x as, let's write that as 1 over cosine x. Let's even write tan x as sine x over cosine x. And cosecant x is 1 over sine x. Now that minus will come out here. Secant x is 1 over cosine x. Cosecant x is 1 over sine x. And cotangent is cosine x over sine x. So now we see some things canceling out. So it seems like sine x cancels here. Cosine x cancels there. And we get 1 over cosine squared x minus 1 over sine squared x, which we can then write using their reciprocal trig functions. That's secant squared x minus cosecant squared x. Now, I find this to be the sort of neatest version of the derivative, but technically the derivative was done when you were just even at this stage here. So this is the derivative, but if you're asked to simplify what's circled in yellow, it's kind of nice to return back to secant and cosecant x, and there's some symmetry there, which is very nice also. So for our second practice problem, we're going to find the derivative of this quotient. So call up the quotient rule, set up our structure, and u, the upper function, is cotangent x, and v, the lower function, is cotangent x plus 1. And the derivative of cotangent is negative, don't forget, cosecant squared x. And actually, therefore, this will have the same derivative. So to find f prime x, let's set up the quotient rule. We start with u prime v, so that's negative cosecant squared x times cotangent x plus 1, so it's one diagonal, and then minus u is cotangent x, and v prime is negative cosecant squared x, and the denominator is cotangent x plus 1 squared. Now notice that you can't rewrite that denominator without foiling out, so we'll just leave it put as that. And I'm just going to tidy up a little bit now, because this negative, this and this make a positive. I'm just going to bring that to the front and write that as cotangent x cosecant squared x, and then minus, I'm not going to distribute the cosecant squared x into cotangent x plus 1, and you'll see why shortly. So that in the denominator is still this. So now what I'm going to observe is that it seems like cosecant squared x is a common factor to both terms in the numerator, so I'm going to pull that out. So cosecant squared x, factor that out, and I'm left with cotangent x minus cotangent x plus 1, but that negative will distribute in to make minus 1 here. And that's all over cotangent x plus 1 squared. And then conveniently, these cancel, and we are left with negative cosecant squared x over cotangent x plus 1 squared. So hopefully by doing some more of these, you get to familiarize yourself with memorizing the derivatives of the different trig functions. So our last practice problem is to find the equation of the line tangent to the curve y equals tan x at x equals pi over 4. Now, this is the equation of the tangent line that was generated in a previous video, but we're not using function notation here. I mean, we could replace y with f of x, but let's go back to just old-fashioned point slope form that you would have learned in Algebra 1. So x1 in this case, x1 would be the value of x given to us, pi over 4, and y1 would be the y-coordinate associated with that x-coordinate on the curve, which we find by just plugging pi over 4 in to the function. So tan of pi over 4 equals 1. As for the slope, we need to first find the derivative of the function. So we have a formula, and because we just derived this in this video, we know that dy by dx equals secant squared x. That allows us to find the slope at the point pi over 4 comma 1 by just plugging in the value of x in here. So secant squared pi over 4. Now secant pi over 4 turns out to be radical 2, and we square that, and that gives us 2. So if we assemble this together, the equation of our tangent line is y minus 1, that's y1, equals the slope 2 times x minus pi over 4, because that's x1. So this is the equation of the tangent line, and right here I just have a visual of that. The red graph is tan x, and I typed in that equation of the tangent line and it delivered me that blue line, which is a perfectly fit tangent line at the point of tangency, which is pi over 4, comma 1. And that brings us to the end of this lesson. I hope you found it helpful, and if you did, please do click like and or subscribe to my YouTube channel, Ready to Derive. Thank you.